In the image-to-video workflow, we add an end frame condition so that the model can gradually evolve from the first frame to the last frame. This is called first and last frame to video generations. This represents a significantly greater challenge. The model can no longer freely extrapolate from the beginning, but must plan a coherent trajectory that ends precisely at the desired target by the last frame. Currently, among open-source video generation models, only a few support start-end frame functionality, with major examples including CogVideoX, LTXV, Wan 2.1, VACE, Wan Fun InP, and Wan 2.2. The most typical applications of start-end frame videos are main subject transformations or scene transitions to achieve camera cut effects. In this demonstration, I will use these two images as the start and end frames, creating a transformation video from smoke to a human silhouette. Load the start-end frame workflow of the Wan Fun InP model. The overall process is similar to standard image-to-video generation, with only two minor differences. First, image input and processing require both the start and end frame images to be provided. Second, since the last frame generated by the Wan Fun model is sometimes not identical to the input end frame, I added an extra node group to forcibly replace the final frame in the video with a customized end frame. If you don't mind it, you may skip this step. Let's take a closer look. First is the model loading step. Wan Fun InP is a model developed by Alibaba PAI team based on Wan 2.1. Here I chose the lightweight version, which has only 1.3B parameters and can run easily on consumer-grade GPUs. You may also use the 14B parameter model for better results. The text encoder, VAE, and clip vision model are the same as Wan 2.1, EMT5 XXL, Wan 2.1 VAE, and clip vision H, respectively. Optimization and acceleration methods follow Tcache and enhance AE video. Image processing differs from standard image-to-video generation in that you also input the end frame image. Choose suitable prefacing methods such as resize, crop, or pad to ensure the start and end images have identical dimensions before feeding them into subsequent steps. Besides serving as the start image, the start frame must also be encoded by the clip vision model as a reference input. In previous text-to-video and image-to-video workflows, the positive prompt was always complexity, but things are a bit different here. With the strong constraints provided by the start and end images, prompts mainly describe the change and dynamics. However, if you are accustomed to specifying detailed elements in the scene, feel free to include them in the prompt. I typically use large language models or plugins to generate specific prompts. Negative prompts have little influence and are usually left as default or blank. For sampling, use the case sampler or its variants for different models and workflows. Just follow the recommended settings for steps: CSV, sampler, and scheduler. The difference lies in the sampling preparation nodes. For this workflow, we use Wan Fun InP to video rather than the Wan image to video node used by Wan series models in text to video or image to video. Nonetheless, the logic is encapsulated within the nodes. Users mainly need to provide an extra end frame image. Subject transformations with simple backgrounds are relatively easy scenarios. Here I usually generate 33 frames. Too many frames tend to result in repeated or meaningless content. My custom end frame replacement procedure is as follows: extract all frames from the generated video except the last one, append the input end frame as the last frame, and then compose the final video. I will show you a comparison of the results after running it. There's not much to say about video decoding and saving. Just remember, if you encounter errors during decoding, switch to VAE decode titled. Click Run. Lightweight models are fast. Results take around a minute and a half. The transition from smoke to figure is quite natural. Comparing the actual final frame generated with the input end frame, they may look nearly identical at first glance, but subtle differences remain. In some situations, it's crucial for the start and end frames in the finished video to match the input exactly, making the end frame replacement step very meaningful. Besides Wan Fun, the start-end frame generation capabilities of Wan 2.1 VACE, Wan 2.2, and LTXV are also quite good. LTXV, in particular, is very fast and effective. To use these models, simply replace the model loading and sampling node groups in your workflow, and adjust prompts and parameters as required. Now, let's look at how the building blooming effect shown at the beginning of the video was made. Select a building image, use depth ControlNet and a blooming LoRA to generate a matching building image covered in flowers. Then input these two images as start and end frames into the workflow you just saw. it's easy to generate a building blooming video effect. With this workflow, you can combine various LoRA or image editing models to achieve many creative and practical effects. However, perhaps due to the complexity of training and the prioritization of features, open-source video generation models lag behind in this area. They are noticeably less capable than text-to-video or standard image-to-video formats.